Hi to everyone. So MEM School of Engineering, Department of Mechatronics Engineering, online classes, analog devices and circuit. Unit number 3. Okay, in this class, we are going to discuss about voltage to frequency converter and frequency to voltage converter. That is, in voltage to frequency converter, we are going to change the output frequency with the input voltage. That is, if we are changing the input voltage, means the output frequency of the circuit will be varying. As well as in the frequency to voltage, the output voltage changed or controlled by the input frequency. Okay, with respect to the input frequency, this is the concept of voltage to frequency and frequency to voltage converter. This is mostly used in the transmission purpose and the receiver purpose. Okay, that is V out is equal to K into F. This is the voltage to frequency converter. Example is TC9.00. That is 100 kilohertz low power dissipation, single or dual power supply operations. That is 8 volt or 15 volt. So temperature stability, DC to 100 kilohertz, programmable scale factors. So this is the internal diagram of the TC9.00. So that is voltage to frequency converter. So this is the output waveform of voltage to frequency converter. That is, output voltage will vary the input voltage will vary the output frequency. That is, if we are varying the input, means output frequency will be varying. This is the concept of voltage to frequency converter. So then frequency to voltage converter. So we can use this circuit as also frequency to voltage converter. So these all the circuits are dependent on the basic capacitor model. So basic capacitor and synchronization model. So that is, it is having the op-amp, delay circuit, self-start circuit, then integrator, differentiator circuit. Because when timing, if you want to compare to signal, it will generate the some square wave, as well as the circuit will be having the triangular wave. So output common, frequency to output, amplifier output, this amplifier output pin, the operation amplifier. During voltage to frequency operation, a negative going ramp signal available in this pin. So in this frequency voltage to mode, a voltage proportional to the frequency input is generated. The zero adjustment pin. This input is non-inverting input of the operational amplifier. The low frequency set point is determined by the adjusting the voltage at this position. This voltage to frequency converter operates on the principle of charge balancing. The operation of the DC 9400 is easily understood by the referring this figure. The input voltage is converted to the current by the input resistor. The current is then converted to the charge on the integrating capacitor and show up a linearly decreasing voltage at the output of the op-amp. The lower limit of the output swing is set by the threshold detector, which causes the reference voltage to be applied to the reference capacitor of the time for a time period. So long enough to charge the capacitor to the reference voltage. So this action reduces the charge on the integrating capacitor by a fixed amount. Okay, so there is Q is equal to C reference and V reference, causing the op-amp output to step up a finite amount. So these are the two models used for the different level for applying the frequency to voltage and voltage to frequency converter. Thank you.